So hi everybody, welcome back to this video of series data structure. Today we are going to cover this topic queue. We are going to cover singly queue in this video, starting with what could be the real life example of a queue. So you can consider people in a maze standing in a queue waiting for their time to come, and so that they can go for their lunch and pick whatever the items they have arranged. So that could be an example of queue, or a person standing on a ticket counter, like looking to buy tickets. So the first person who stands in front of the queue are gonna get the ticket first, or are gonna get out of the queue very first. And people from the rarer, like from the last of the queue, they are gonna get part of the queue. So to give you a pictorial view, I will just draw it in array format, since we are going to create an array for it. So you can consider this is your ticket counter TC, and the people are standing in a queue as P1, P2, P3, P4, and keep on going. Now this is the front of the queue, and this could be the rear of the queue. Let's say our queue is currently empty, and like not empty, we have only 4 person in the queue, and the rest of the queue are like places are vacant. So this is the rear. If any new person comes in and would like to be part of this queue, he have to go stand the person behind this rear, and the very first person who is going to get out of the queue and get the ticket would be the P1 that is standing in the front of the queue. So this is what queue is. If we look into the implementation of the queue, so like to give you a logical implementation, it would be like any person standing in the front would get into the queue will be the first person who is in the queue. So queue works on first in first out, that is first in first out FIFO, or last in first out. Last in last out. So basically it's FIFO only. We generally pronounce it as a FIFO. So the first person who enters the queue would be the P1 in this current queue, and he will be the very first person who is getting out of the queue and getting ticket from the ticket counter. And then once he popped out of the queue, then there is a turn for P2. And if another person, let's say P5, would like to be part of the queue, so we'll first point the rear to here to like just behind P4, and assign it to P5. If we look into the implementation of the queue, so the language we are going to prefer is Java only, and this is a singly queue. So only like there will be no circular part and everything. So we'll be covering it in the later part of the playlist. So the implementation would be like we have a class, say singly queue, and the data members would be like we have 2 pointers, front and rear, to point from where we need to get the person out of the queue, and from where we need to insert the person, fresh person to the queue. So it would be like I have a two private variable denoting front and rear. So let me just erase this one. Okay, I'll just draw a fresh video. So this would be the picture. This is rear, this is front, this is our ticket counter, that's TC. So we have front and rear as 2 pointers to the queue, through which we are going to insert new elements or the new person into the queue, or we are going to pop out from the front of this. So these are the 2 pointers. Initially, like this will be the 2 pointer, and again we need this array to maintain who is like entering into the queue or who is not like getting out of the queue. So we need to maintain this array as well. So our array will be like a private int array, and this is it. Now we need to assign some initial values to it. So the data members, this much data members for a queue is enough. And in case of if we are inserting, let's say not int, it's a person. If we would like to insert the name of the person to the queue for an information, then instead of int, we could simply use the string data type. Since let's say I'm inserting the identification number of the person, so ID number. So in this case, I'm maintaining an integer variable, integer array variable, right? So now I need to initialize the values. So I'll just create a constructor. So let's say also like for this constructor, you need the capacity of the array. Like let's say how many members we can fit in the queue. We do have a limited number of person that could stand in the line of ticket purchasing queue, because like there will be a limited space. So the very first thing is like once the arguments accepting this constructor would be the capacity itself, as we were doing in the stack part. So I'll just provide a capacity here, and now let's say at initially if there is no person in the queue, then where this all values will be pointing. Let's say my array is if I'll just rotate the array by 90 degree, rotating by 90 degree, it would look like this. So this would be the front, this would be the rear. So any person who already got into the queue, the very first person would be at the front, that is P1, P2. This way it will go, and the very last person who got to be the part of the queue or the array are standing at the rear position. So let's say at initially if there is no person standing in the queue, so our queue is empty. In this case, yeah, exactly. So our front and rear both will be pointing to nothing. Like I need something to denote there is no person in the queue. The queue is empty. For that, I need to assign this front and rear to some integer variable, since we are storing as an integer identification number. Identification number could not be like a negative number. That's why I'm free to use the -1 or any negative number. But in future we'll have to use this negative number only to identify if the queue is empty, or if our front or rear is pointing to that particular negative number, or we are free, our queue is underflow. So in these cases, I'll just assign the values to front and rear, that is front rear to -1, and I'll just I also need to store this capacity as well. So in case our queue is full, then how would we be able to know that our queue is empty? So in Java also there is a function like array.length. So if our rear is matching with this, then we would be able to know our queue is empty, queue is full actually. But for now, we'll just instead of going into this complexity, we'll just create a separate variable that represents the capacity of our queue. So let's say I've provided the capacity. Initially, once I am running my constructor, I'll assign the capacity to this. Let's say I just named it as a cap, and cap variable would be assigned a value of capacity. Our integer array would be of we need to assign some memory to integer array, that would be like int of cap. So this is enough for our constructor, since now we do have our queue ready with initialized value of front rear and array with capacity, we're calling it as a cap. So two basic functions will be needing while inserting and popping an person from the queue. It will be is our queue full or is our queue empty. So in case our queue is empty, we cannot pop any element or pop any person out of the queue. And similarly, if our queue is full, in those cases we cannot insert more people, or we cannot make another person stand in the queue or be the part of the queue, right? So in those cases, I'll be needing this two function, that is two methods. So I'm keeping it as a private because I need not another person or any other class to access this member of singly queue. So I'll just the return type would be boolean only, is full would be the very first function. Sorry again. So this would be the is full function, and we will be needing another function that is also a private type only, that would be boolean is empty. So we need to complete these two functions at very first before going into inserting new elements or popping or deleting an element from the queue, or traversing the queue. So also we'll be needing this if our queue is empty, we can also not traverse the queue because there is no element inside it, right? So whenever we're checking if our queue is full, then in these cases, if we are inserting an new person or new member to the queue, then we'll be doing it through rear only. And if rear is pointing to the maximum capacity of the queue, then there is no chance we can insert another element or another person to the queue. In those cases, we'll just use a conditional variable, that is rear is equals to cap of -1. In these cases, our queue is full, so we'll return true. Otherwise, we'll return false. We can insert the false would state that we can insert an element of the person to the queue, since our queue is not full. So when we go to our is empty function, is empty would be let me just erase few things right from here. I'll just draw it to the bottom so that you can always have the picture of what our queue is. So this is a ticket counter, this is front, this is rear. So when will be the case where our queue is empty? So queue will be empty if our rear is pointing to -1. Initially it was pointing to -1, right? Or there is no element, then that's where this negative number whichever you are taking will come into the play. So if our error is pointing to -1, in this case our queue is empty, so we'll return true. Otherwise we'll return false. So I'm just giving you a free space. You can screenshot this, save it, or note it on notebook. Pause the video and note it over your notebook. So now we do have two functions: is full, is empty. Now we are ready to insert an element or delete an element from the queue, and also the traversal, right? So I'll just erase these extra methods, and we'll go on writing the insertion and deletion of the queue. So let me just erase this one. Yeah, I'm leaving the data members right here because we'll might be needing to reference these ones since we have used these variables name. So now we need to insert an element, right? Let's say we do have a queue. We like I'll just write the method right here. Void insert queue, and I need a argument that is data. I need to insert it, right? So I need to first check if our queue is empty or full. Like if our queue is full, we cannot we can no more insert any other person to the queue. So I'll just simply check if our queue is full. I'll just simply print out like our queue is full, and I no more can insert an element to queue, and I'll return from this method. Okay, now I need to insert an element to the queue. So the insertion would be like since our front is pointing to this one and rear is also pointing to this -1, I need to insert this the very first element to the rear, right? So I'll just increment the rear and insert the data member there. Data would be anything like the person or person, like let's say data is P1. Front would be front would be pointing to -1 only. Rear would be pointing to this 0th index, and we'll insert the value to the location 0. Now we have an data to rear, but again here is a problem. Let's say like in future cases more element come, we'll just increment the rear and we'll insert the value to the queue. But the problem is like the front. If we are going to delete, we are seeing like our error is pointing to -1. In this case, we'll just simply return like our queue is empty. We are not pointing to anything. In those cases, to prevent that, we need to increment the error as well in the very first case, where like the very first element we are inserting, we'll need to increment the error. So the function would be like sorry. The function would be like if front is pointing to -1, increment front, and this is it for the insert function. Let me dry run this one. Dry run would be like if our queue is empty, if our queue is full, we can no more insert the element to the queue. We'll just simply run this block of the code and return of the method. If our queue is not full, we do have a space or the capacity to insert a new person or the element to the queue. We will like increment the error and will put the person or the data to that value. Let's say I need to insert the value in this case. Then firstly error will be pointing to this one. Now I will increment error incremented. We'll put the value data here, and this part is done. Now we'll check if this is the first element we are inserting. We'll increment the front as well. This is the first element we are inserting. That's why we need to point the front to this one as well. This is not. This is it for the insert function. The delete I need to do. So we need to delete, perform the delete operation on the queue. Let's say we have inserted few elements to the queue, that is P1, P2. Let me remove this data. P1, P0, P1, P2, P3. We have inserted few elements, and now I need to perform the delete operation. Now front would be pointing to 0th index as usual. Front would be pointing to this one, rear would be pointing to this one. Right? So let me change the name of this function as will delete queue, and there is no need of passing an argument. The return type would also be int. Okay, we need to check the very first condition, and if our queue is empty. If our queue is empty, we cannot no more like delete from the queue. So if is empty is true, we'll just simply system.out.println that our queue is empty. and we'll return of this function. Since the return type is int, we need to ensure we are returning something as an integer variable, right? Integer value. So since like these are identification number of the person, like we are storing the identification number of the person in the queue, that could not be negative. I can choose any negative number. Since I am using -1 as a standard in this code, and I'll be returning -1 itself. Now we need to delete this, delete something from it. Like for that, I'll be deleting from the front. So I'll just return array from front, and that will be minus, and this is it for the delete operation. So the very first person, that is P0, that would be reserved. Front would be incremented. Front would be incremented to this one, and this P0 would be returned. So this is the case. This is it for delete operation. Now we need to travel, like one more thing you might be thinking, that is like we'll keep on like inserting an element to the queue. That is like, let's say I have inserted P4 and P5 as well, and now our queue is full, and rarer is pointing to this index, and front is pointing to this index. This is 0th index, that is like empty. P0 is considered to be deleted from the queue. Now if we keep go on inserting another element or the P6 person to the queue, that would like return our queue is full. We cannot insert the new element to the queue. So but still we have the issue, we have this memory that is empty, the place that is empty. We would have like inserted something here, but we did not. To solve this issue only, we do have a concept of circular queue. We'll be studying in another video of this playlist only. For now, we'll go with simply singly queue, and in singly queue, this space would be wasted. However, the element would be deleted from the queue, front. That the memory location would be wasted only. So the next would be like traverse. Queue. System.out.println. Traversing queue. Okay. Now I need to run a for loop. So I need to traverse, like print these all elements present in the queue at current point, right? So the elements are present in between front and rarer. So we'll be traversing from front to rarer. Int I is equals to front. It will go till rarer. And since it is an incrementing 1 to 2, 2 to 3, 3 to 5, 4, 4 to 5, so I'll just write an increment function, and then system.out.println, we do like printing the elements from the index I with space in between, and this is it for the, like, this is with the for block. This is the for block. This is the method block. So this is it for the traverse. So I believe this much is enough for the single queue. We do not have very much things to know in the single queue, but it have a great importance while you'll be practicing the TSA questions or the competitive programming questions. No, then in those cases queue have a great importance. It will play a very vital role. So like keep on keep watching this video till you got a grasp on it. If you do have still any confusion, or if I have missed any point in the explanation, you could like simply comment it down. I'll just go through each and every comment, explain it over there. And if I feel like if like a lot of person is having the same issues with some of the concept which I have explained, so I'll try making another video on that if that would be the case. Otherwise, that's all for today. Thank you everyone. Bye bye.